Okay, now that we know how to do two-dimensional arrays, we are going to write a Minesweeper game. There's a number of versions of Minesweeper. I don't know if it still comes with Windows, but it did for a long time. You get a 10 by 10 board, and so there's 100 cells on the board, and you have to guess where the mines are. And what you do is you click on a cell, and if there is a mine there, you lose the game. If there is not a mine there, it will come up and with a number telling you how many of its neighbors are mines. And what you have to do is you have to deduce where all 10 of the mines are. When you think you found a place where a mine is, what you do is you plant a flag on that location. Okay? And we typically do this in one 75-minute class period. So let's see if we can get that done in about that time on video here. So here is the notes document for Minesweeper. We're going to use a one-dimensional array. We're going to use a two-dimensional array for the board. We need to be able to select random board locations to plant the flags. We need to be able to do a little sorting algorithm, and we need to be able to get input from the mouse so we can click on the squares. So Minesweeper is going to be a two-dimensional array. It's going to have 10 rows and 10 columns. Initially they're all covered, and you can right click or you can left click, and we need to keep track of the following. Is there a bomb in that cell? Yes or no? So that sounds like a Boolean. Has the cell been uncovered, which means the user clicked on it? Has the cell had a flag planted on it? Yes or no? And how many neighbors with bombs does it have? And where is it located on the screen? And that will be a rectangle. So we're going to create a struct called cell that will hold the 5 elements above. And it's going to be a two-dimensional array, and we can make it 10 by 10, but when you're counting neighbors, that's difficult. So what I've got down here is actually a 12 by 12 board. For a minute, pretend that this outer border is not there. So if I want to count the neighbors for this guy right here, I can't check a neighbor here, 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 because they don't exist. So when I'm doing a corner cell, I've got to check for 3 neighbors. When I'm doing other stuff along the top or the bottom or the right or the left, these guys have 5 neighbors, but they don't have 3 on this outside border. If we simply make our array 12 by 12 instead of 10 by 10, then we can put our 10 by 10 array inside of it. And if we have a 1 cell border all the way around, you can pick any cell that's in gray here, which is our playing area. You can pick any cell there and look at all 8 of its neighbors. Everybody has 8 neighbors in this case. There are no special cases. And it's much easier to use a little bit of extra space like this than it is to try and allow for all the special cases you might have for counting up neighbors. So that's what we're going to do. So we will declare a constant called board size. We'll set it equal to 10, but we're going to use board size plus 2 for sizing the array. Okay, so we'll get 12 by 12. We need some pictures. Initially, everyone will be blank. If we click on a bomb or a mine, this is what gets displayed. If we want to mark it, this is what gets displayed. If we click on a blank one and there's no bomb underneath, then what shows up is the number of neighbors that particular cell has. Okay. Now, we have a problem we haven't had to deal with before, and that is planting the mines. Okay, we're going to have 10 mines hidden, and we need to pick 10 random locations out of 100. And if we use a random number generator, we may or may not get exactly 10 bombs. If we do like a 10% random number generator, we might get 10 bombs. We might get 9 or 11 or 8 or 12 or something. So what we're going to do is we're going to figure out a way to make sure that we get exactly 10 bombs. So here's what we're going to do. We're going to create an array of 100 Booleans. Each one corresponds to a cell on our 10 by 10 grid. We're going to set the first 10 values to true and the last 10 values to false. Each one that's true is going to represent a place where a mine is located. Each place where it's false, there is no mine. So this will give us exactly 10. But obviously they're not randomly distributed. They're in the first 10 cells in our array of 100. So here's how we're going to randomly distribute them. We're going to step through the array, and every time we get to an element, they're going to be numbered from 0 to 99. We're going to look at element 0 first, and we will generate a random number from 0 to 99 to swap it with. And then we'll just swap the false and the true. And then we'll go to the second item, item 1 in the array, and we'll swap it with a random number. We'll go to number 2, swap it with a random position, and we'll do that 100 times. And by the time we get done, then everything will be randomly distributed throughout the array. Okay, so let's take a look at the code. I'm giving you the code for this. So we're going to create a new random number generator called rand. We're going to create a new array of booleans. We're just going to call it n, and 100 elements. And then we go through and set each one to false. And I guess I did this the opposite. We're going to put true in the last 10 locations. So going from 90 to 99. So we've got 90 places that do not have a bomb, and we've got 10 places that do have a bomb. And then what I want to do is I want to look at each element. So start at element 0, go all the way up to element number 99. And generate a random number between 0 and 99. And then I'm going to call that position, or POS. And I'm going to take the current element and I'm going to make a copy of it in a variable called save. Then I'm going to take what's at the random position and I'm going to copy it into the current element. Then I'm going to take what I saved, I'm going to copy it into the random position. So I just swapped those two elements. If you want to do a swap, the swap is always going to be 3 instructions like this. Okay. And then, just to make sure that I've done it right, I'm going to write out, I'm going to dump out my array, but I'm just going to do it in text format. So I'm going to go from 0 to 99, and if it's true, there's a bomb. So I'm going to write out an asterisk on the screen. Otherwise, I'm just going to put a dot on the screen. And when I get to row number 10, I'm going to go down and start on a new line. So I'll actually get what looks like a 10 by 10 array when I print out my results. Okay. I have already downloaded and opened from our home page. I've downloaded and opened the program shell, and I've declared quite a few things in here for you already. So we have a cell structure, and this is the data we need to keep track of for every one of the 100 cells that are on the display. Our board size is 10. We're going to make that a constant. Our cell width is going to be 48 pixels, and 48 pixels, if I do 10 by 10, it's going to give me 480 pixels going across and 480 pixels going down, which means it will exactly fill my default screen size in the vertical direction. Then I create a two-dimensional array of cells. This is cell structs, rather. That's what this looks like. I'm going to call it cell 12 by 12. I need a texture for the bomb, I need one texture for the flag, and I need one texture for a blank, so I'll be reading those in. I need an array of 10 textures, and what I'm going to do is I'm going to store my textures. An element can have up to 8 neighbors. A cell can have up to 8 neighbors around it that don't have bombs, and including the number 0. So this is going to go from 0 to 0 to 8. And I'm going to hold the images 0 through 8 so I can pop them up on the screen when the user clicks the mouse on a given cell. I need to know what the mouse is doing now and what it was on the last tick. We have a Boolean called game over. Okay, there aren't really any game states here, except for game over. So at the beginning, I want to make my mouse visible. I want to initialize the board. I want to plant some bombs. I want to count some neighbors and set game over to false. Okay, so I've got blank functions here that we're going to fill in. Load content is already loading everything for me. So the numbers 0 through 8, which I numbered with the words 0 through 8 over here, will get loaded into locations 0 through 8 in my numbers array of textures. And then I've got separate variables for the bomb and the flag and the blank. In update, nothing really yet. In draw, nothing really yet. Okay. If I were to run this program right now and stop it right here, I think it would only tell me. Let's run and see. Okay, the program has started to execute. We've stopped on the last curly bracket here. If I go to my numbers array here and click on the little arrow, it will show me, let me see, click on the arrow there, and it gives me all of the values for that particular item. It does not show me the texture, but that's okay. So that takes care of the setup, and I'm going to try to break this video up into smaller chunks. So we will stop there, and then we'll actually start writing some code in the next video.